A new moon has suddenly appeared near Earth, except it's not orbiting our planet, it's orbiting the moon. What? A moon having its own moon? How did this mini moon form? Is it here to stay? And how would this affect us on Earth? Okay, before we throw ourselves into the orbit of our planet's largest natural satellite, let's take a look at how our moon came to be in the first place. To do that, let's step back, about 4.5 billion years back, to one of Earth's most impactful moments. Scientists theorize that in the early years of our solar system, there was another planet in our cosmic neighborhood, known as Theia. And even though this planet could have been about the same size as Mars, we don't have much evidence to prove it because, well, Theia no longer exists. That brings us to the Great Impact hypothesis. According to this theory, Theia and Earth were both in orbits that doomed them to a head-on collision. And when these massive celestial bodies bumped into each other at high speeds, the impact was, well, as the name suggests, quite great. Enormous amounts of material were ejected from both planets, but all this debris didn't just drift off into outer space. Instead, it formed a dense ring of molten rock, dust, and gas around Earth. And over the course of a few million years, this material lumped together under the forces of the planet's gravity, merging into one single object, an object we know today as the Moon. So, if this is the story of how our gravitational companion came to be, does that mean we should be bracing for the Great Impact Round 2? Well, that's not the only way moons can form. And by moons, I'm of course referring specifically to submoons or moon moons, which are all just different ways of saying the moon of a moon. Still with me? Okay, good. Beyond the Great Impact hypothesis, which requires millions of years to play out, there are faster routes to acquiring a moon. Some moons are fully formed objects that are captured or pulled in by the intense gravitational forces of a celestial body. Take Neptune's moon Triton as an example. Theorized to have been a large icy body in the Kuiper Belt region, it may have been captured by Neptune's gravity after a close encounter. This massive gravitational disturbance could have ejected the object from its original orbit and pulled it into its own. Over time, Neptune's tidal interactions forced Triton's orbit to go from long and elliptical to nearly circular. And in case you're wondering how this theory came to be, well, it's because Triton, unlike other large moons in the solar system, orbits in retrograde. And no, that doesn't mean its vibes are off, like when Mercury is in retrograde. It just means that it orbits in the opposite direction that the planet spins in. Okay, in order to avoid the mess of a giant collision, let's imagine that our own moon's moon was a captured object, like Triton. Maybe it was once an asteroid, passing just close enough to Earth to avoid a collision, and even closer to the moon to find itself trapped in its orbit. This would make for an incredibly delicate gravitational disruption, big enough to be locked into the moon's gravity and small enough not to disturb the moon's orbit around Earth. The object would need to be a bit of a Goldilocks. One study suggests that in order to maintain a stable orbit around our moon, this object would have to be no bigger than 1 kilometer in diameter. And even if this asteroid were to succeed in becoming a moon, well, it wouldn't stay one forever. It would be constantly tugged and pulled in different directions by the tidal forces of both Earth and the moon. That would mean there'd be a chance of it getting ejected from its orbit, or colliding with the moon. So its entire lifespan as a moon might only end up lasting a few years or decades at most. During this short window of time, the moon would have little to no effect on us back here on Earth. Well, physically at least, but that wouldn't mean that it wouldn't become an object of endless fascination to us. Throughout history, the moon has been a source of inspiration for myths, legends, and folklore. The sudden appearance of a small moon swinging around it would inspire a whole new wave of stories, art, and no doubt plenty of conspiracy theories. But beyond the stories we'd get to tell future generations of our moon's moon, scientists would have an opportunity to study a celestial phenomenon like nothing we've ever seen before, and so close to home. Observatories and telescopes could focus on this tiny object to study the ways that different objects interact with forces of gravity. This would help us collect data and predict similar events happening in far-reaching parts of our cosmos. But mostly it would give you something new and exciting to gaze endlessly at in the night sky. Until one day when it may appear to drift away back into the depths of space or careen downward into a rocky impact. And if you weren't keeping a constant eye on it, well, you better hope someone was, because amid the tidal tug-of-war between our planet and the moon, there's a chance that the moon eventually collides with us here on Earth. In this event, the moon would behave just as you'd expect any asteroid to act. Headed toward Earth, it would enter our atmosphere and then begin to generate intense heat as it encounters the friction of the air in our atmosphere. Considering its small size, there's a good chance it would likely break apart before making impact. But if it stayed intact, well, that could spell trouble for us. Traveling at an average speed of 72,000 kilometers per hour, this asteroid could smack down right on top of your city. Now, the amount of energy released by an impact like this would be equal to thousands of megatons of TNT. I wonder what would happen if a much bigger object came crashing down onto Earth. How much worse could things get? Okay, it's time to switch things up a little. What if Earth suddenly shrunk to be the size of the moon, and the moon expanded to be the size of Earth? How would you be able to fly on this tiny Earth? Why would you never see the moon again? And could humans on Earth survive this catastrophic switch? This is What If, and here's what would happen if the moon and Earth switched sizes. Okay, before we see what happens if we switch things around, here's the baseline. If Earth shrunk, everything on Earth would become smaller, but in proportion to each other. Earth would have the same land, continents, mountains, oceans, crust, and iron core, only shrunk down to the size of the moon. And just to keep it simple, we'll call this new Earth Little Earth, and the larger moon would be the big moon. Little Earth would be smaller, but humans, animals, and plants would stay the same size. So buckle up, it's about to get very crowded. Our regular-sized Earth is about 4 times larger than the moon, and it's 80 times heavier. But not today. Today, these celestial bodies are in for a big switch-up. Little Earth would now become a moon of the big moon, and it would start to orbit around it. But I'll get back to this a little later. First, let's talk about gravity. It would be massively different. For any celestial body, the force of gravity depends on both mass and radius. Little Earth's radius would be around 1/4 of what it used to be, but its mass would only be 2% of a regular Earth. This is a massive change that would definitely make your life harder, or lighter. I mean, on this little Earth, you would feel lighter because gravity would only be 27% of Earth's original gravity. If you were 70 kilograms on regular Earth, well, now you'd only weigh about 19 kilograms. That's good news for me because I'm really bad at working out and dieting. With this new low gravity, moving around would be way more fun. You'd feel like Neil Armstrong bouncing around on the moon, only you'd still be on Earth and you don't need a spacesuit. Places that used to be far away would suddenly become so much closer. New York to Paris, well, it's no longer 6,000 kilometers and 7 hours away. Now it'd just be 1,500 kilometers and less than 2 hours to fly. It would take less fuel to get there, but also less fuel for aircraft to launch into the sky thanks to low gravity. Now, it's great to weigh less, float around, and get to Paris in no time at all, but I'm afraid there would be some bad news. We humans evolved on a planet with much higher gravity, so we're not adapted to living in a low-gravity environment. Over the course of just 6 months out in space, astronauts can lose 13% of their muscle mass. Now, being in low gravity wouldn't be as bad as being in zero gravity, but your body still wouldn't like it. Your spine would break down and lengthen, and you'd have constant back pain. Your muscles would weaken, and with less gravity, your body's fluids would move up the body more easily, resulting in what some scientists call a puffy-faced bird leg syndrome. Yeah, it's exactly what it sounds. You'd have tiny legs and a swollen face, and your eyes would get damaged. Meanwhile, the big moon would now be as wide as Earth and would weigh about 2/3 as much as the original Earth. Well, guess what? Its gravity would increase by a lot, too. Right now, the moon's gravitational pull is only 1.62 meters per second squared, but with this new size, its gravitational pull would become 5.96 meters per second squared. That's like 60% of regular Earth's gravitational pull. Just because there's no life on the moon that we know of, it doesn't mean it wouldn't be a big deal, because the gravitational pull from the new big moon would create havoc with something else: little Earth's tides. On the regular-sized Earth, the tides are 1 meter high, give or take, but if the moon suddenly became much heavier, it would pull more violently on the surface of Earth. What used to be a tide would now be a tsunami. Say goodbye to coastal cities like New York and Venice. They'd be flooded and wiped out. Millions of people would die. And that's only the beginning. The gravitational force from Big Moon would pull so hard on Little Earth that it would deform the Earth's surface, cue massive earthquakes and extreme volcanoes. This is because gravity would be acting on Little Earth's molten core, similar to how Jupiter causes volcanoes to erupt on its moon, Io. Now, remember I said you wouldn't need a spacesuit on this new Little Earth? Yeah, forget that. You definitely need one. You're able to survive without one on Earth because our planet has a wonderful, thick atmosphere. It has oxygen for you to breathe, and it protects you from the sun's harmful radiation. But on the new Little Earth, well, we're going to lose our atmosphere, and this would happen really quickly for two reasons. The first and most immediate one is gravity. Regular Earth's gravitational pull is strong enough to hold the atmosphere in place, but with a sudden drop in gravity, the atmosphere would start to drift off into space. Big Moon might actually pick up some of these gases, and who knows, maybe this gray rock would become the newest, most livable place in the solar system. Even if Little Earth held on to a little bit of its atmosphere, there's a second problem that would hack away at it over time. With its smaller size, Little Earth would cool more rapidly. Over time, it would lose all the heat from its molten core. That's what happened to the moon when it formed 4.5 billion years ago. Back then, it was molten too, like Earth's. Maybe you're thinking, what's the big deal with losing our hot molten core? I'll tell you. The outer part of the molten core is what gives our planet its magnetic field. Earth's magnetosphere also helps to hold the atmosphere in place. Without a magnetosphere, solar winds would strip away the atmosphere. Of course, losing all of Little Earth's atmosphere would mean you wouldn't be able to breathe, and as the atmosphere is slipping away, the temperatures would become extreme, like a desert. During the day, it would get extremely hot, and then at night, the temperatures would plummet. Little Earth would likely hold on to its ice at the poles, just like Mars did, but all the liquid water from our oceans and lakes would boil away. And that would pretty much be the end of life on Little Earth. Without an atmosphere, you'd be exposed to so much radiation from the sun that even if you managed to survive this far, you'd be suffering cancer and cataracts. Your nervous system would get fried too. While little Earth would lose its atmosphere pretty quickly, our magnetic field would take longer to disappear. It took about 200 million years for the Moon to lose its once existent magnetic field. Over those millions of years, there'd be another major change on this new little Earth, and I mean major. Our Earth would stop being a planet. To explain this, I need to roll back a bit. The Moon is tidally locked to Earth. By that, I mean the Moon takes the same amount of time to make one rotation on its axis as it takes to do one revolution around Earth. Because of that, one side of the Moon is always facing our planet. In our new scenario, after millions of years, little Earth would eventually become tidally locked to the big Moon. At first, the big Moon would make little Earth slow down. And after millions of years, this Earth-Moon system would reach equilibrium. Only now, little Earth would orbit the big Moon, and we would always face this big Moon with one side. Well, that would make Big Moon a planet, and little Earth, well, we'd be Big Moon's moon. With tidal locking, though, one half of our planet would never see the big Moon in the sky. Are you ready for another mind-blowing change? Well, the length of a day on little Earth would no longer be 24 hours. It could last as long as a month. You'd have half a month of darkness, followed by half a month of daylight. On the bright side, all-night raves and pajama parties would last a really long time. Oh wait, at this point, you'd be long gone thanks to the extreme temperatures, volcanoes, earthquakes, and even more extreme radiation exposure. But what about Big Moon? Well, since it was already tidally locked to Earth, that tidal locking would stay in place even after the switch. Now both would be tidally locked to each other. Okay, you know what? We're going to stay positive and let you survive all the catastrophic events on little Earth. Somehow. You'd still be struggling to breathe in a thinning atmosphere. Your body would be taking a beating from the low gravity, temperature extremes, radiation, earthquakes, volcanoes, tsunamis, you name it. Your life on this little Earth would be miserable. But on the positive side, the big Moon would look awesome up there in the night sky. It'd glow 4 times as bright as before, and you'd get to see total solar eclipses much more often. With all the problems on little Earth, Big Moon would start looking like a much more attractive place to be, at least in a couple of ways. For one, it would have more gravity than little Earth. Plus, it's sitting in the Goldilocks zone in terms of distance from the sun, so if we moved there, we'd get the same amount of solar energy as we're used to. The two big problems? Big Moon still lacks an atmosphere, and there's no liquid water. So if humanity, or whatever was left of it, wanted to settle on the Big Moon, well, we'd have to build an atmosphere for it. One way we could do this is to break the Big Moon's crust to release gases from underneath it. And fun part, we'd do it with nukes. With the new higher gravity, the Big Moon would have a better chance of holding on to this new atmosphere. Then, with a basic atmosphere in place, our next step would be to get some water out of the water ice at the Moon's poles. The regular-sized Moon has about 6.6 billion tons of water ice at the poles. But of course, with the new Big Moon's size, there would be several times more water ice than before. After freeing up the water, plants could be introduced to produce more gases and create some oxygen. The first steps toward a moon base would be in place. But how would we transport supplies to Big Moon from Little Earth? Well, one bit of good news is that with Little Earth's lower gravity, it'll take a lot less fuel to launch a spaceship to the new moon. We could use Starship technology to make a moonship to establish a settlement on the moon. So maybe humans will somehow find a way to survive. We've survived catastrophes before, and hopefully we will again. But what if, instead of trying to establish a new home on the Big Moon, we doubled down our efforts to get to Mars? Well, that's a story for another What If.